So I have told you previously that we need to understand the concept in more detail in our observable variables. So for understanding these concepts more accurately, you need to have some data set. For example, if I need to load the data set here, there is an option here with select data files. You need to click over here. You you need to click on group 1 working. It will let you the data. uh, the smart pls have some example data files you can use, but I have my own dataset files that I can use here. For example dataset file, I can load here. I click OK, and you will see with a couple of with some seconds it will load here. In order to verify whether your data is loaded or not, you just need to click over here, list variable in dataset. It will show you the data in your file like this. Hello, can you hear me? Please let me know. Hello, hello, hello. I need to mute all. Yes, you audible. All right. Well, I was discussing about this function allows you to draw an observable variable. So, what does it mean by observable variable? In case you are using an observable variable when you have loaded your data set like this, you have some variables like I have calculated SVT, LVT. These are my observed variables which are already calculated, and these are the indicators. If I have already calculated some composite variable like SVT, LVT, I can use this concept like this rectangle concept. So this is a function allows you to draw an observed variable. So let's draw an observed variable over here. Just select it and you can draw it over here. And what you need to do, you should open your variable from here, and I need to put SVT in here. That is short duration training. You can right click over here, object properties. You can shorten its name like this, short duration training. So it will appear like this. It is already calculated. In the same way, you can create another rectangle shape. You can open your data set from here like LDT. I can drag from here and I can put it here. Then I can right click here, object properties, and I can shorten this name LDT, and it will look like this. If you want to move these objects from here, you have move object option. This is how you can move any object. So this sign is used basically to move the object. You can click it again to uncheck. For example, I would like to see the influence of SVT and LDT on some dependent variable. I need to see which dependent variable is here. That is project success. This is my dependent variable. So how can I create it? I will create it this shape over here, and I would like to put here the variable PS from here. Just drag it. I need to put it here, just like it. So what you need to do next? There is a basically this sign is used when you have a dependent variable and you want to add some error time. So in Amos, you need to put this sign over a dependent variable. So let's suppose this is my dependent variable. So in order to indicate my dependent variable and in order to tell the Amos that this is my dependent variable, and I would like to see the impact of SVT and LDT on project success. So I have also added an error term over here. So what I need to do next, I can draw the path from here to here, then from here to here. And as we are using a covariance based technique between independent variable, so we need to create a covariance between both of these. This is how our model works in Amos. These are independent variable or exogenous variable. This is dependent variable. And you need to understand that these shapes are created when you have some measured or observed variable. In other words, if you have calculated uh, your composite variable that you would like to use in Amos, then you should use this basically idea. Let's suppose I would like to see whether I have some composite variable or not. I can open the file in SPSS and I would like to verify which of the variable are composite variable and which are not composite. So composite variable is basically the observed variable in our model. So let me check which of the variables are composite variable and which are not composite. So let's suppose this is basically the data set where I would like to see these are the indicators like SVT 1, 2, 3, 4, 5, 6. So we can say them the indicators. They are going to measure the SVT. But if we have already calculated the SVT using the composite variable technique, which I have told you in the earlier days using transformation and compute variable, it means that we are going to use this as a observed variable. So this is the idea. When you have some observable variable in your data set and you want to run a model based on these observed variable, you should use this rectangle shape. But if you have indicators in your data set, you doesn't have your composite variable in your data set, then you need to use this circle. So let's suppose that we have this model. So how can we run it? There is a calculate estimate button. There is a analysis properties. So let's suppose I would like to run this model. I go to the analysis properties and you can see uh, already maximum likelihood estimation is selected over here. So you just need to select this and you need to have fit saturated and independent model. Uh, you just need to have bootstrap in bootstrap. You don't need to change anything in numerical. You don't need to change anything. You just go with the default model and you need to click the estimate button. The file is in the directory cdrom file. MOS does not have permission to write in that directory. Must be in a okay. I think I need to close the SPSS file first, then I can run it. File is in the directory C program files. MS does not have permission to write in that directory. Must be in directory where MS is permitted to write. Let me check what does it want. Let's suppose I save this on the desktop. Like I am going to save it because I have not previously saved the model. Let's suppose it is my first model. Now I would like to run it. One variable is unnamed. Which variable is unnamed? For example, I think this one. It's want me to name it like yes. Yes. This is error term. Now I would run it. Yes, it has run the model. You can see iteration minimum was achieved, writing output, chi-square. It has run the model. So it is just a simple analysis that I have shared with you how you can, and you can see there is a OK button here with the default model when you have run the model. So there are some options, view the input path diagram model specification and view the output path diagram option. So you can click over here, you can see the output like table it has created, and you can view the text over here. This basically option indicates the output of what you have analyzed over here. So I will let you know. You need to click on the estimate button, and you will see the path from SPPT to PS, that is a positive and significant. Then from the path and the DPPS, it is also positive and significant. You can see the three starret signs under uh, the p-value. So these are the p-values and these are the coefficient values. And you can also see the covariances between them, the covariance that we have created between SDT and LDT. It is also significant covariance and it is positive covariance. It means there is a positive variance between SDT and LDT. Then you can see the individual variances. The individual variance of SDT is 1.273. It is significant. Then individual variances of LDT is 1.380. It is also significant. Then you can see the model fit. Here are the model fit indices of what I have previously discussed with you. This is just an example model. We are not going to discuss this model in more detail, but I will show you some basic model fit over here. As I have previously discussed with you, that when we are going to use the model fit indices, we need to see this table. This is the basic criteria table that will let us know whether we are basically our model is fit or not. So this will indicate the fitness of the model. First, we need to see the chi-square divided by df. So here the Siemens here, and this is chi-square divided by df. So what is this value? 554.948. So as per criteria, this should be less than 3 for good, and less than 5 is sometimes permissible. So we can see here our value for this is 3. But this value is basically not indicating a good measure. We can see here the p-value for the model. It should be greater than 0.05. We need to see where the p-value is located over here. The p-value. The p-value is basically this, and this is not good. The model is not fit. And we can see here the CFI, GFI, they should be greater than 0.90 or 95. You can see here the GFI, these values are lower than our standard level. Like in here, these values are not good. You should see the RMC value. RMC value should be less than 0.05 or between 0.05 to 0.10. So this value is also not good, but it is less than our basic criteria. If you see, this is less than 0.05. So you can see here, it is more than 0.05, so it is not good. So peak loss, what is the criteria for peak loss? It should be greater than 0.05. So here, what we conclude that this model is not fit. This model is not a good fit. So according to the model fit summary, this model is not fit. This model is not good yet. So we should indicate some other criteria to measure it. So this is how you can use a basic model using rectangle shape. Now, the next thing I would like to let you know is how to use the circles. This function allows you to draw an unobserved variable. If you have indicators and you have not calculated your variable yet, you can use this circle. You can drag the circle in the graphic window to size of the circle you want. Note that you will rarely need to use this function. MOS provides a better option for drawing unobserved variable. Basically, when you want to draw any sector over here, or any observable constructs or latent constructs over here, you have two options. Either you need to use this circle, or you can use this option here in order to measure the constructs or measure the latent variable. So let's assume, let's suppose that I would like to use a new file over here, like new. I would like to increase this option here. So I have either I can draw the unobserved variable, or I can use this for latent variable. So let me explain the concept from here. Let's click here, just draw a circle here, all right, and then you can use this one. So let's suppose that I would like to draw this circle for I need to see the set of variable over here. I need to use I need to load the data file, because every time you create a new file, you need to load a data file for that purpose. So let's suppose I need to use the same file that I have previously used from here. Just click OK button and it will be loaded. You just need to open this. So let's suppose I would like to create a constructs based on these indicators: SVT1, SVT2, SVT3, SVT4, SVT5, SVT6. So there are 6 indicators. So on the basis of these 6 indicators, I would like to create a construct which is SVT. So how can I do this? Simply go to this side and create 6 indicators: 1, 2, 3, 4, 5, 6. So it has created 6 indicators. Just click it again and open your variable list from here, and you need to drop one by one each indicator, like SDT1 here, SDT2 here, SDT3 here, SDT4 here, SDT5 here, and SDT6 here. So it will show you the indicators of SDT. Now you can create here the object property, and you will create here the name of your construction, SDT here and SDT, and it will show the construct like this. So you have measured unobserved SDT variable using these indicators, using this sign. So we have assumed that we have an unobserved variable that we are going to measure through some construct. And if you want to change the direction of these indicators, you can simply do it. There is an option of rotate the indicators of a latent variable. All right, you need to select this one, and you need to rotate, yes, this one, like this. From which direction you would like to rotate it, you need to use this. But before that, you need to select your constructs so that you can easily move it. And I would like to move, uh, if I want to select only one object, I want to move it upward. So how can I do it? Select all objects. You simply click on it and you click move objects from here, and you can easily move it. Always remember, if you does not select all objects, it will move only that object which is basically selected. For example, let's deselect all objects. I have selected only this option. If I select the move objects, it will move only this option. It will not move the other indicator. But if I select all objects, it will select all at once. So we can easily move objects from one location to another location. So this is how you can use it. You need to select the deselect option again. Then I can create another uh, option here for LDT. Let's suppose I have created a circle, and I would like to see what other variables have, how many indicators I need to create for LDT. LDT 1, 2, 3, 4, and 5. So there are 5 indicators that I need to create here for LDT. So you need to select it. You need to put 1, 2, 3, 4, 5. So what you need to do, you need to open your variable list from here, and you need to drag and drop your indicator wise data. LDT1, LDT2, LDT3, LDT4, and LDT5. This is how you can do it. Then you need to select this one, and you need to rotate their direction. And again, you need to select this one, and you need to select one by one these options so that you don't need to select other one too, other constructs too. You just need to select all these one, and I would like to move them, yes, in this way. If I select all, it will also select the SVT, but I want to select only this one. So I use the option for selection one object at a time. So select the deselect option. Now, what I need to do, I need to name this construct. Go to the click, right click, select object properties and name it LDT. Again, LDT here. All right. Now, I need to create a dependent variable over here. And how can I create the dependent variable? Again, the same is the procedure. You need to create a circle over here. You need to see how many indicators are in your dependent variables. I would like to create here the PS variable, and the indicators are PS1, PS2, PS3 up to PS16. These are basically the indicators. So I need to create here 16 indicators. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I can create it and I need to select them all. I need to click on the construct first and then I need to change the direction like this. You can decrease your view to make it more comfortable for you like this. All right. What I need to do, I need to put my data one by one in these indicators. So I go to the variable, I go to my PS indicators one by one, and I will put those indicators and drag and drop those indicators in my model like this: PS1, PS2, PS3, PS4, PS5, PS6, PS7, PS8, PS9, PS10, PS11, PS12, PS13, PS14, PS15, and PS16. So I need to change the name, that is PS and PS again here. So this is how I have selected my model. Now, what I need to do next, I need I need to relate this model. This is my DB and these are my IDs. Always remember that you need to name your error term here. These are the error terms. These are the error terms of your indicators. So you need to name there. So name parameter, name unobserved variable. So you need to click on it and it will create the names automatically of your error terms. So how I did it, if I click on Control Z, how I created the name of error term, I just go to the plugin, I go to the name unobserved variable, just like you just need to click on it and it will automatically create the name of the error term. Then this is our dependent variable, that is F1. Why it is F1? I have created a name. All right, this is CS. All right. This was my dependent variable. So previously I have told you that in case of my dependent variable, I need to create an error term over it. So how can I create? This is the option that I can use over here. just like it. And I need to create a covariance between my independent variables, just like it. So I need to create a path from here, from here. And this is a simple path. If you want to analyze the structural model, you can run this model here. But in order to do this, you can see here the error term of your dependent variable is still having no name. So you can go to the plugin, you can go to unobserved variable and it will name it. So let's suppose I will analyze this model. Go to the analysis properties. Uh, let's suppose I would like to find out the generalized least square other method, and I would like to see the estimated mean and intercepts. And in numerical, I don't need to change anything. Biasness, unbiased maximum likelihood method output. What I need to see in the output, I need to see the standardized estimate, the minimization history, the standardized estimate. I need to see the correlation of estimate, the covariance of estimate, the factor score weights, which means the factor loading score. Then residual, no, sample moments, no. Bootstrapping, I don't need to do any bootstrapping here. Permutation, random, no. All right, I need to estimate this model. The observed variable SPT is represented by an ellipse in the path diagram. SPT. There is an issue with the SPT. Why it is not indicating? So these are basically the issues in our model that every time indicates whenever we are going to run the model. Let's suppose I would like to run only the measurement model only. Let's suppose I doesn't want to run the structural model over here. I just want to run only the measurement model. So how can I run the measurement model? You just need to correlate all of your variables. You need to correlate all of your constructs like this, like this. To run it, again, this is given some issue. I will see what issue is being raised, but you need to simply run like this for measurement model. But before doing it, I will like to elaborate some basic idea, and I will see in my tomorrow session what are the issues that are being raised. So this is basically the indicator. This function allows you to draw an unobservable variable that includes indicators and error times. This is the primary function you are going to use for drawing unobservable variables because it will include the indicators. So you will initially draw or drag a circle to size you want, and then left click on this circle to include an indicator. If you click twice on the unobservable circle, MS will include two indicators. You can choose the number of indicators. If you have drawn the unobservable constructs and indicators but forget to add an indicator, just select this function and click on the unobservable. It will add another indicator. Then for what purpose you can use this sign? You can use this sign to indicate the path. You can have this sign for indicating the path if you want to create a structural model. So this sign is used basically to indicate the path or parameter between two objects or constructs in the graphical window. Just like this, you can create a path model from this. Then this sign is basically used to create the covariance between two constructs that we have created here. So this is the sign for creating the covariance, because the MS basically support the covariance structure of the model. So you can create it. Then you can have a lot of other options, like this is the way you can create covariance. Then this sign is used basically in order to create uh, uh, the error term on a dependent variable. So this function lets you add an error term to the variable normally in your dependent variable. If a variable already has an error term added, then selecting this function and clicking on the variable again will rotate the error term. You can select the position you want your error term to be located. So this sign is basically used to indicate a dependent variable in your model. Then I will elaborate today the basic tools that are being used in our estimation. You can see here, this is the dependent variable, and we have created an error term over the dependent variable. We have created some path over here, and between independent variable, you can see the covariances that are indicated. So this is basically the Meyerman model. The values you are seeing here are the factor loading values. So please join again for the last part of this session. It will take only 20 to 30 minutes to complete the last part of the session. I will discuss some basic tools here, and we will discuss the advanced tools in tomorrow's session. So please join again. So I will discuss some basic tools that are remaining for today's session.